Hi girls, these are the notes for the sine rule. This is a rule that's used when we do not have a right angle in our triangle. So for non-right angle triangles, when we want to use sine. Okay, so I'm going to derive this, which means I'm going to do a little proof of how the sine rule came about, and you're not going to be tested on this, but just watch what I do so you have an idea of where it came from. I'm going to drop a little height in this triangle that's a non-right angle triangle, and in triangles you'll remember from year 7 that we name A, B, C, big letters for the angles, and little letters for the sides across. So across from A, I write little a, across from C, I write little c, and across from B, which I'm not going to use, but if I did, it would be, you know, a little b down here. Okay, now I'm going to do a system of simultaneous equations. Wow, that's a blast from the past. And I'm going to say, okay, angle A. I'm going to say the sine of angle A is equal to opposite over hypotenuse. Opposite over hypotenuse. And therefore, h, or this height here, if I were finding it, is equal to A sine A. And likewise, I could go into this triangle that I've split up, and I could say the sine of C, pick C, is equal to opposite over hypotenuse, h over A, and so h is equal to A times sine C. Well, h and h are equal to each other. They're both the same size height there, and so I know A sine A equals, whoops, did I do that right? Opposite over hypotenuse? Geesh, I'm making mistakes like crazy, you wouldn't believe. C sine A equals A sine C. All right, now I'm going to just divide this by sine C and this by sine A so that I get C on sine C equals A on sine A. And this is this formula that I developed where I get the length of a side over its angle is equal to the length of a side over its angle. Okay, let's just use, I could write it out. Why don't I write out the sine rule properly, and it says C sine C, we got that, equals B sine B equals A sine A. All right, so let's use it down here. Now what we need to have, on this one it says, calculate the length of the side marked X and the triangle shown correct to 1 decimal place. So I need to have the thing I want to know with the side across from it, or the angle across from it, excuse me, and then the angle and the side across from it, and I have to know both of these. So I have one unknown, and I'm always going across, right? All right, so I start with what I don't know. So I say X over sine of the angle across from it, 80, degrees equals 16 side on top over angle on the bottom, sine 40 degrees. Now I'll just grab my calculator. You won't believe that I made a video before this and did this whole problem wrong, and so I'll have to do it again. So here we go. Sine, or 16 divided by sine 40 degrees is that. And so I get X over sine 80. I know it's loud up here. Sorry girls, it's rough. And then I need to multiply by sine 80 since it's under the X. Whoops, let me put that up like that. So I go times by sine 80 degrees, and I get 24.5. And I'll put it in whatever, it looks like centimeters. Okay, cool. Let's look at another one that's got a little bit of a trick to it. Okay, the next one's a little bit of a twist because it says calculate the length of the side labeled Y, but sadly I don't have the angle across from Y. I do have this, my known one, so that's good, but I don't have this angle that's across from Y, so I need to figure it out, and you'll think about it right away that a whole triangle adds to 180, so I'm going to subtract off the two other angles from 180, and I'll end up getting 40 degrees. And so I'll say Y side over sine of angle equals side over sine of angle. And I'm going to do this on my calculator, this division, try to ignore that screaming, times by sine of 40 degrees. All right, so here we go. going to do 16 divided by sine of 65 degrees, and I'll hit enter, and then I'll do times sine 40, ending my brackets each time. And I will get y equals 11 point, this one's interesting because it says correct to 4 significant figures. So let's look on here. This is 1, 2, 3, 4. So I round to that 4. I'm going to make it a 5. 11.35. Try it on your own calculator. See what you get. Okay, and that would be meters. Okay, I want you to try this one. I'm going to pause, and then I'm going to write the answer out for you. You try it first, though. Okay, magic. I hope you paused and tried it, but that's what I got, my setup and then my answer. Okay, now when we're finding angles, we have to flip the rule upside down. You don't have to, but it really, really helps. So instead of writing a sine A, I write sine A over little a, and sine B over little b, and sine C over little c. So let's calculate this angle that they've given me. I have this set up, which is really good. I have everything I need. So I'm going to go sine, it's always sine, theta over the side opposite equals sine 110 over, I think this is 20, okay, over 20. And so I'm going to go sine theta equals, and in my calculator I'm going to put sine 110 divided by 20 and then times by 6. And when I do that, I get that sine theta equals 0.2819. Now remember, when we're doing this, I'm going to try to make this a bit darker for you guys. Maybe even focus it a little bit. That's a little bit better. And remember, when I'm finding an angle, I have to do the sine inverse of that. So I'll go second sine, and I'll put that in 0.2819 in the brackets, and I get 16.4, we'll say. So theta is approximately 16.4 degrees. Okay, great. That's it, girls.